Okay, so for this set of notes, we're going to be solving logarithmic equations. So first couple things we just have to remember. If you see log of x, then the base, remember, is 10. And if you see natural log, then the base is e. So the steps for solving logarithms. First, simplify each side using properties of logarithms. Meaning if you have logarithms that are being added or subtracted together, remember we can combine those into one logarithm. So that's what you want to check for first. After that, there's two basic types of problems that we're going to be looking at. One is when we just have one logarithm, okay? In this case, we are going to rewrite it in exponential form and then solve it using methods that we know how. And then the other type is when we have two logarithms, so a logarithm on each side. If this is the case, then basically those logarithms can just go away and you set up an equation where you have x equals y and then solve there. Last, we have to check for extraneous solutions. We didn't have this issue with exponentials because you can plug any number into an exponential. The domain is negative to positive infinity, right? With logarithms, remember the domain is between 0 and infinity. So you can only plug in positive numbers. Now that doesn't mean that if you get a negative answer, it's necessarily wrong. You just need to go back up to the original problem and make sure that you're not taking the logarithm of 0 or a negative number. And I'm going to show you what I mean when I go through these examples. Okay. So first problem. Also, with the directions here, it says solve the equation and give exact values. Exact values mean that I don't want you to do any rounding, okay? I don't want you to change it to a decimal. So we're just going to leave it, not have decimal answers. So for this first one, we're going to end up getting the logarithm by itself on one side. So the first thing we need to do here is divide by 4. So that gives us the natural log of x is equal to 9. Remember that with natural log, the base is e, so I usually just go ahead and write it in because now I want to rewrite this in exponential form to solve it. So I have e to the 9th is equal to x, and that ends up being my answer. Okay, that's going to be a humongous number. We're not going to write it all out. To check it, so anytime I check it, I'm not really checking to make sure I got the answer right. I'm really just making sure that it's not an extraneous solution. So I go look up at the original problem and I look at where the logarithm is. Okay, so I just need to make sure I'm not taking the logarithm of a negative number. And so I know that this x value here, whatever that is, which I got e to the 9th, I need just to make sure that that's bigger than 0. It's a huge number. It's going to be greater than 0, so I'm good. Next one. So I already have the logarithm by itself on one side of the equation, so this is going to be where I rewrite it in exponential form and then solve it. So I'm going to have 3 to the first power equals x cubed minus 5, and now I just need to solve for x. So I'm going to go ahead and add 5 to both sides. 3 to the first is just 3, so I'm going to end up with 8 equals x cubed. Take the cube root of both sides. I get x equals 2. So to check this one, again, I just need to make sure that I'm not taking the log of a negative. So this entire thing right here cannot be negative. Okay, so when I write this, I really have x cubed minus 5 has to be greater than 0. So I'm going to plug it in and make sure that that's true. So 2 cubed is what I would have here. 2 cubed is 8. 8 minus 5 is 3. That is bigger than 0, so I'm good. And that's how you check to make sure you don't have an extraneous solution. Okay, next one. So you can see that we have logarithms on both sides here, but I can't just get rid of them yet. I have to go ahead and combine these first. So remember, when you're adding logarithms, you can write it as one logarithm, but those expressions need to now be multiplied together. So this is the same as log of 2x plus 1 times x, and then is equal to log of x plus 8. And now that you have just one logarithm on one side, one on the other side, the bases are the same, now we can get rid of that logarithm, okay? So now I have 2x plus 1 times that x is equal to x plus 8. And now we can go ahead and solve this. I'm going to distribute this through. 2x squared plus x equals x plus 8. Anytime you have a quadratic, so an x squared, remember we need to get that equal to 0 and factor it. So I'm going to move this stuff over, get it equal to 0. So I have 2x squared. In this case, the x's go away. And then I have the minus 8 equals 0. Okay, I'm going to take out the 2. So x squared minus 4 equals 0. Then I'm going to go ahead and factor. Remember that x squared minus 4 is a difference of squares. So I have 2 times x plus 2, x minus 2 equals 0. And then I can just go ahead and solve. This gives me x equals negative 2 and x equals positive 2. Okay. Now I want to go back and check and make sure that with both of those solutions I'm not plugging in a negative. And right away you can see right here, this is just log of x. So I cannot plug in this negative 2. So that is an extraneous solution. If I look at positive 2, I think I'm okay. Okay, here this would give me 2 times 2 is 4 plus 1 is 5, which is positive. Here 2 is positive. Here 2 plus 8 is 10, which is positive. And so I don't have any issues with that. So x equals 2 works. All right, next one. Same type of thing where I have two logarithms on the same side. They're being added together, so I need to go ahead and combine these first. So this would give me log base 3 of, so 4x plus 1 times x plus 1 is equal to 3. Now, in this case, I don't have a logarithm on the right side, so they're not just going to cancel out. This is going to be one where I have to rewrite it in exponential form. So the base, right, to this power gives me this. So 3 cubed is equal to 4x plus 1 times x plus 1. Then I can go ahead and solve this. 3 cubed is 27. This I need to FOIL. So I get 4x squared plus 4x plus x plus 1. I need to go ahead and get this set equal to 0, so I'm going to move this over and simplify. So I'll have 0 equals 4x squared plus 5x minus 26. So here, off to the side, I'm going to go ahead and do magic x with this. A times c, so 4 times negative 26 is negative 104. Middle is 5. So remember, I need to find two numbers that will multiply to give me negative 104 and add up to 5. Probably use my calculator to figure this out. 13 and negative 8 work. And then we need to divide by 4, that number out in front. So when this factors, I'm going to have 0 equals x plus 13 over 4. And then x minus 2, that negative 8 over 4 simplifies down. So this would give me two solutions. X equals negative 13 fourths, and x equals positive 2. So now I need to go back and make sure that both of these give me positive numbers, okay, up here. Now, negative 13 fourths is negative 3.25. So right here I can see negative 3.25 plus 1 is still going to give me a negative number. So this one is not going to work. Okay. A positive 2, I'll have 8 plus 1, so 9 over here, and then 3 over here. So that one works. So my answer is 2. A couple more. Again, on the left side, I'm going to need to combine these. It's a little different because I'm subtracting now. So remember, when I write this, as a combined logarithm, I need to divide. So this is going to be log of x plus 6 over x plus 2 equals log of x. Now I have a logarithm on each side. I can go ahead and get rid of that, so I really just have x plus 6 over x plus 2 equals x. Okay. Now to solve this, I need to get the x plus 2 out of the denominator. So I'm going to multiply by x plus 2 on both sides. That leaves me with x plus 6 equals, I'll go ahead and distribute, x squared plus 2x. And then again, it's a quadratic. I need to get it set equal to 0. So I'll go ahead and subtract this stuff over. 0 equals x squared plus x minus 6. Do magic x. So negative 6 and positive 1. 3 and negative 2 work here. I'm just dividing by 1. So I have 0 equals x plus 3 and x minus 2. Solving gives me x equals a negative 3 and a positive 2. Making sure that we're not taking log of a negative, I need to look up here. Here I'm going to have an issue, right? Log of x. So I cannot have a negative number there because I'd be taking log of negative 3, which does not work. Positive 2 I think is okay. Yeah. So final answer here, only one that works is 2. Okay. And then last one. All right. So this is kind of weird, right? If you just look at the e to the natural log of x, those are going to undo each other, right? So these actually cancel out, and we're just going to be left with the natural log of x right there. Minus natural log of x minus 4 equals natural log of 5. Here I need to combine these. Since I'm subtracting, it's going to become division, so natural log of x over x minus 4 equals natural log of 5. Since I have the natural log on both sides, that I don't need anymore, so I have x over x minus 4 equals 5. Solving kind of using the same strategy. I want to multiply by that x minus 4 on both sides. Over here it will cancel out. So I have x equals 5x minus 20. Here I don't have a quadratic, so I don't need to get it set equal. I just need to get the x's on one side. So I have negative 4x equals negative 20. Divide by negative 4. I get x equals positive 5. Okay. I want to make sure that I'm not going to take the log of a negative anywhere. So here, that's fine. Here, 5 minus 4 is 1. That's fine. And then here, it's natural log of 5. So I'm good. All right, your homework. Page 489, numbers 37 through 69, every other odd. So 37, 41, 45, so on.